Good afternoon, everyone, and welcome to this session of the DARS Talk Series here at Texas Tech University Huckabee College of Architecture. It is a real pleasure to introduce today's speaker, Arthur Mamou-Mani, a Franco-British architect whose work redefines how we approach digital fabrication, sustainability, and architectural production. Arthur is the director of Mamou-Mani Architects, an award-winning practice known for its eco-parametric approach, merging computational design, material awareness, and circular thinking. His work has earned international recognition, including the American Architecture Prize, the Riva Rising Star Award, and the Pierre Cardin Prize for Architecture from the Académie des Arts in France. He's also a lecturer at the University of Westminster and a recognized public speaker who has presented his work worldwide, including at several TEDx conferences. Alongside his architectural practices, Arthur founded FabPub, a digital fabrication lab in London that empowers people to co-create using large-scale 3D printing and bio-based materials, promoting open source and participatory design for a more sustainable future. Please join me in welcoming Arthur Mamou-Mani.
Cheers. Thanks. That's actually, it's a very nice intro. I should, please send it to me. I need to use that. Nice. You can all hear me okay? You can see my screen? You see the right screen? Okay, good. I did the lecture once and I was sharing the wrong thing and okay, good. It's all good? Okay. Nice, nice. Well, it's an honor to be speaking here and thank you, Sina, and thank you for this amazing intro. And I wish I was with you in Texas, but I'm here in London. Nice. So I guess I've heard from Sina that you are both interested in architecture, also in fabrication, but equally in entrepreneurship. And so it's good because that's the kind of topic I want to cover. And entrepreneurship and design making is sort of all the topics we're going to cover. So, it's not the usual lecture. You can stop me. I'm sure if there is something, a pressing question, feel free to say. I will have a bit of time together. I've got, I think, about an hour with you, 45 minutes. So it's plenty of time to take our time. And so please stand back, just, try to kind of even take notes and let me know if there's anything that doesn't make sense or you can challenge me. All open. So I'm here in our office. We've got a architecture office, Mamou-Mani, and we've got a fabrication company, FabPub. We're about 20-ish people now from all over the world. And we have the chance of having this sort of yin and yang relationship. Our architecture office delivers projects of all sizes, and our fabrication company is a sister company, it's a separate company that's got investors and that really wants to empower others. So it just shares our tech with others. Architecture, I'm sure you know, is a very specific sort of service-driven business. When it comes to fabrication, you are a little bit more quote unquote scalable because you are providing others with technology. When you do architecture, you have a notion of authorship, and that's sometimes centralized, sometimes harder to scale. Definitely always trying to kind of get projects. In fabrication, you're a lot more open to others and open to sharing technology. So I just thought it would be nice to have this sort of yin and yang between the two. And so that explains having two offices. All okay? Yeah. Fantastic. Okay. So we are an office of 20. I'm sure it's the same in the US. Very importantly to know why we're together, what drives us. And in that sense, we have to write a small constitution, let's say, at the scale of a company. And most importantly, being French and British now, in France, we like to complain a lot. And the truth is, when you're an entrepreneur, you can't really complain. You have to change things. So be the change is our main driver. And I say this because, and I won't read all of our values, But when it comes to trying to change things, you're going to be confronted with a lot of hurdles, and you can't really complain your way out of hurdles. You're going to have to find out about regulation, fire regulation, uh, the all kinds of technical, financial processes that it takes to actually have an impact. And so all these are rules of how we do that, and they're shared across the office, and people can align with it or not. They can change it, they can challenge it, but this is the core of what we do. I worked at sorry, I see you took a picture of that. Okay, great. I'll go back to it. Yeah. I also hate when I'm about to take a slide and then the speaker changes. So, but in essence, that sort of philosophy infuses. I used to work at Zahadid Architect, and I wasn't quite sure what we were about. And of course, there is an implied style, but I think we're trying to thrive for something a bit deeper than style. And so in that sense, I just thought if I was joining an office, I'd love to be given a bit of a constitution, let's say. And so that helped us also see beyond the forms and deeper into the systems of what we're doing. Because parametric thinking ultimately is thinking with systems rather than shapes and forms, I think. So this is a old bridge that was disused for about 300 years in the water, and we dismantled it and created the tower on the left from it. It was relatively rough, of course. It still had the traces of being underwater for 300 years, but timber is amazing. Some timbers are denser than water and can sink. This is called ironwood. And so we created that sort of soft skin around it. The skin itself is inspired by this Balinese culture. It's in Indonesia, and they've got this 3-axis of harmony between humans, harmony with nature, and harmony with the higher forces, let's say. So we got this from the Balinese culture and created these models for them. And it was important because architects, I guess it's natural. We build stuff, so there's going to be something instead of nothing, let's say, when we start doing something. And so, ultimately, I speak about the environment. It's probably better for the environment if we didn't do anything, but at some point we need to take a decision and do something. So it's that moment of decision that is so important. We're roughly responsible for about 40% of all carbon emission in the construction industry. So the tower is made from reclaimed timber, and then the skin is made from rattan. Rattan is a palm that is really abundant in Southeast Asia. And so the idea was just to try and guide that process through. Also, when you use parametric tool, you're tempted to differentiate everything and have some kind of component that varies all along it's very tempting. I remember when I learned parametric design, but things like symmetry and repeatability just emerge as much more efficient. So striking a balance between differentiation and repeatability is often our challenge, whilst keeping, of course, the inspiration and the beauty. So in this case, the skin becomes a canvas at night for artists. They have their projection mapping on the skin of the surface, and that helps bring a kind of again, a sort of bottom-up cultural aspect to the structure that the culture embraces rather than rejects. This is a hotel in Yucatan where we took every time I go to this sawmill, I have these pictures on the right where I find local fabricators, and all wood can bend, really, more or less. You can assist the bending through steam or water, but the good thing is you can see the limits of the bending and inform your computer model based on the limits of the material. So rather than shape something in the computer and then impose it, you could start from off-the-shelf sizes or sawmill sizes. And I say this because then what you can do is to bend things according to the things you find in the market. There's a reason why timber has a certain size, and you buy it at 2x4 inch or 4x4 inch and so on. And so you don't want to change that. And equally, if you put everything and laser cut it and you have all these wastes, you're just like, is that really economical? And should I do that? And that's the first thing I think we learn, is to laser cut everything, and that's part of digital fabrication. But really, could you inverse that and start from the materials you buy and think of the size of the standard sheet and size of standard timber? So this, for example, was starting from the straight line and seeing what happens if you just unfolded a straight line into this kind of Chinese lantern-like structures. And so we took it in a tool called Kangaroo and made sure that the segments were always straight. And so they bend in 3D, but when you unfold them, they're straight. And we used what's called steam bending in order to constrain it to be into these three-dimensional eyelids, which then create a structure that's elongated and covers quite a big area. But ultimately, it's made from one single tree, an ash tree. So all of this is just one tree. So wastage is kind of really interesting when you think about it, both economically and in terms of environment. Obviously, they're both linked, by the way. I know, one can speak more than the other, but the financial value and the economical value and the environmental value are often linked. I'll speak of when they're not linked, and that's more of a problem. But it's not obviously just the environment. It's also the affordability of what you're creating. This is a staircase that's a bit crazy, but it's the same. There are standard planks that are bent at different angles. And sometimes that's enough to create the sort of delicateness and the variations that are needed to create an effect, an aesthetical effect. And really, I guess that's what we're hired for. We're still architects after all, and beauty is often what convinces. These are plywood sheets. We use this open source way of hinging. It's called a lattice hinge. It's online. You can go in the instructables.com. You can download these patterns. And I just downloaded one, and then I mapped it on a surface where we could change the U and V direction. And by doing that, it created this sort of seemingly double curvature effect on timber. And that's very unusual because if you want to create 3D, usually you either, do a waffle structure but in this case, just a plywood sheet just bent into these curvatures. And what this does is then create a sort of acoustic / light diffuser we call the wooden waves. And then the openings, I don't know if you can see, but the openings are wider when the hinge is wider, and then they disappear when the hinge is tighter. And so what this does is that the pattern relates to the curvature. And so it's not an imposed pattern, it's a sort of resulting pattern. And I think that creates something more natural than if I just took a sheet of metal and cut it off. And so it feels natural, I think, because the things emerge from their properties, not imposed as a kind of top-down gesture. This notion of top-down versus bottom-up is probably the best thing I've learned when I studied here in London. And you can see the S curve, what we call an S curve, I guess, it looks like an S, is tangent to the edges and then bends and then goes back to tangency. What this does, it creates a continuity between the shingles. And so you might see a seam, there's always a seam in architecture, a panel, but really what you see is the continuity between them. And that's, when you turn on the light, everything gets revealed. So you get this secondary atmosphere, let's say, from those panels. These panels come back in many of our projects, indoor, outdoors. But here it's interesting because it transitions to a sort of 3D printed version of that pattern, because here we needed strength. It couldn't be bendy. So we switched to a mixture of polylactic acid, PLA, I'm sure you're familiar with it, with the wood dust. So very often, and that's a new thing, and I'll show you more example, people send us dust and then we compound it with PLA, and then we create all these compounds, whether it's coffee or bamboo or stone. And that's nice because it opens up a whole new world of material science. So that's been really, really kind of new and exciting for us. This is the headquarters of Orange. I don't know if you know Orange Telecommunication, the equivalent of AT&T, I suppose, in the US. And they had this problem during COVID. well, everyone had that problem. Everyone was working from home. They had just bought a headquarters. They had issues in their previous headquarters of, mental health, and it was pretty bad, suicides and stuff like that. So it was quite a heavy burden and responsibility to bring them back to work. uh, and we thought, there's this very big, aggressive, long wall of, and then so they said, oh, can you soften it a bit? And so I thought, like lava flow that cracks open to reveal some warmth. Um, this symbolism, we sort of forget about it when we do science and architecture and parametric architecture. We talk algorithms and stuff, but we forget that ultimately you have to speak to the soul. And there's something about parametric design that allows to do that. I'm still very French, so like wine. When you see different wines, they're all made from grape, but somehow you have a sommelier, and then every wine has a different taste and slight different variations of cepage. Like, but ultimately it's all grape. And I tend to feel like parametric architecture, you can take a component, you can take something that's very dull, like a sheet of plywood or whatever, and create the tiny variations that creates the beauty, because in the relationships, you see that beauty, the slight variations of elements. And so I think that's really important, because you can kind of have a very cheap material and maximize the inexpensive material through relationships, through systems. So these are very, very flat. I mean, I was told at school, why you do origami? Origami is on scale. So maybe I took it as a personal challenge, but that's a very 150 meters long, I think that's 600 feet, I think, structure. And so obviously to modularize it, I could do an entire lecture on stuff like that, but we're always confronted to components versus intent. This is a restaurant in East London. They serve like the stuff they usually throw away. They make dishes and it's like a Michelin type restaurant. And this is made from PLA as well, but we mixed it with a fireproofing, obviously trying to see if we can keep the biocompostability of the material, but it's always a challenge. Now we're facing fire regulation, and so we have to. So when you're an architect, usually you just sort of draw something, put it on Revit, and make a procurement sheet or a scope of works, and then you go and buy the products that exist. When you have a printer, or when you don't just do representation, but you actually do the thing, you sell the materials, you're suddenly a supplier of material. And then people ask you for what comes with this. They compare you. Number one, they mentally compare you with someone who mass produces tiles in China, and then you're there with a printer in London, and they have the same mental expectation as someone who sells you tiles. And we face that this from the seams to the pricing to the warranties to the regulation. You suddenly are confronted to all of that, and one does not expect that, just thinking, okay, I'm going to focus on the technicalities of the prints, but not everything else. From the narrative all the way to regulation is the broad range of stuff you deal with when you turn what you're doing into a business. This is a lift, so that's a corporate lift, as boring as it gets. And then they said, well, can you put a cloud in there? Everything okay? Sorry, am I rambling about? I think it's been 16 minutes. Okay. So anyway, so we put a cloud in that lift, and now it's a big event, because whenever it's kind of, you don't expect that, and then it opens up and you have this party inside. I'll talk to you about parties and Burning Man, but just a little kind of corporate intro to that. The scale of what we do is often, I just want to skip to that sort of scale before I bring you to the desert and talk about other aspects of our work. But this is a competition we won in France. Our competitors, so this is a helium aircraft factory. Helium aircraft are coming back. They can live about 60 tons of timber, for example. So it's very promising, and they could be the trucks of the sky in the future. And they're very, very. The helium is lighter than air, so it's very carbon neutral type thing. But basically, that's the challenge. This is 80 meters times 3 if you're in feet, and that's 200 meters long. So yeah, times 3 if you're in feet. So very, very long. And so a structure of that size, usually they do hangars, which are straight. And then what we did is we took it to, say, parametric tools, Grasshopper, and then we linked the structural analysis with the deflection and those waves. So you see those waves here? You have amplitude and frequency. And then we said to the model, namely genetic algorithms, we said, well, change the amplitude and the frequency until you remove deflection or minimize deflection under its own weight, under wind. And then you let it run overnight. And then we came back the next day and we had saved about 50% of steel from our competitor, which, their cylinder was about 2,600 tons of steel more. That's very big. That's about 4 or 5 times the size of Central Park. If Central Park was covered in tree, that's the amount of carbon saved by using genetic algorithms or algorithms to minimize the amount of materials based on just adding slight curvature. So that's the power of parametric design beyond shapes. I mean, I find it beautiful. Looks like a kind of cocoon of sort, but it is mostly that, the satisfaction of having saved that much. Obviously, it's a lot of money saved for the client, but it's a huge amount of carbon as well. So I just thought it'd be nice to show you that. And taking you to that crazy project we did in 2018 called Galaxia. That was the temple of Burning Man. Has anyone in the audience been to Burning Man? Sina, you've been to Burning Man? Wow, okay, nice. Okay. So, I mean, you don't have to go, it's an experience in its own self. But basically, what I thought was interesting is they have 10 principles, and I find this principle quite relevant to, let's say, future thinking or circular thinking. Leave no trace, gift economy, self-reliance, decommodification, radical self-expression. Everyone is the artist. You leave no trace. You bring everything with you. Can't complain again. So it's very entrepreneurial. You have to think of how you come in, the power needs, the sewage needs. There's no sewage, obviously, but you have to think of every single component. So it's very Buckminster Fuller. It's very Spaceship Earth kind of thing, although very polluting, very controversial, very like any utopia confronting itself. But I just thought that would be interesting to teach. So I brought my students there. They built structures over the years, and then eventually we built a temple. The temple is a secular temple, doesn't have a religion associated. It's just a very interesting place where people can come together and share things they want to let go of. And so, I'll show you the inside, but really on a purely technical level, this is 60 meters long and 20 meters high. So again, sorry, times 3 if it's in feet. So probably one of the largest structure they built there. And it was really challenging because we had to build it out of off-the-shelf materials. There's no columns inside. Every single member of the structure is working. You can see the analysis here from our engineers. You can see the newtons going through it. And so we had to adapt the off-the-shelf timber to the forces. So like your bones that take a certain amount of loads, and this is a lattice, so every single member works. And usually we're used to, hierarchy and structure. You have the main columns, you have the beams, you have the purlin, you have the skin. But here it's like, okay, no, let's just build a giant bone thing where everything works, every member works. And it's quite confusing, but really satisfying to build something like this. And the joints were ratchet straps, because the nodes were too complex. So we couldn't build nodes of metal. So everything is trapped together. It's quite kind of a unique approach. And the engineers were obviously, no one was really paid for this. And we had to fundraise a fortune for that. And so every single screw matters. If a timber screw can be $1, imagine times 10,000. So the engineer said, we give you the newtons, we give you the formula, so you know exactly how many screws, obviously plus a certain buffer. But that's what a screw can take. That's what a bolt can take. These are compression and tension. First of all, maximize tension because you don't want heavy elements. So we maximize the tension, and then we took the exact amount of screw needed. And so that's unusual. Usually you take the worst case scenario and you multiply everywhere. And that's why architecture is so wasteful. But imagine you could do the exact amount of attachment in the exact amount of places. And so that's how it looked like. You had a 4x4, a 2x4, half a 4x4, everything was thought through as it comes from the Home Depot, you know. um, but imagine a Home Depot structure at the scale of, yeah, of a cathedral, you know. So we couldn't put foundations, so we had to think a bit outside the box. So we put a bike wheel in the center, like a giant bike wheel with cables that would connect to the center, so the whole thing could not spread. We had to do full scale prototypes. Obviously, it had to be tested against, say, scaffolding and build sequence. Every single day mattered, so we couldn't waste time. We had a month in the desert, had to do a certain amount of module per day. It had to go boom, boom, boom every day, thinking of, a build assembly. We were general contractor, so to speak. I mean, it's not like there were titles at Burning Man, but we were in charge of everything. And that's a sort of thing, like not only, I talked about fabrication, but general contracting, organizing people, organizing volunteers, was hard. So we made this sort of IKEA drawings to people, trying to understand what those were times 400, because there were 400 modules. Thankfully, there was symmetry, so we called it the learning curve, because once you know how to do one of those columns, you get faster and faster and faster. So if I were to scope this against time, like plot this against time, that people accelerated. So symmetry is a really good way to learn. And we started from the very top because it's the most intricate. And so people go faster, but they get more tired. So if I were to plot the graph of tiredness and complexity and, and spirit, and you lose them because they want to go and party. And then you just, you got them because they're excited to be early. And if I were to plot all the human curves as part of this parameter, I'm like, we're going to start from the top, mostly because then you feel like you're there, because the top is usually what you do last. And then you just have to reconnect it to the ground. And so these are a lot easier to build because they're bigger. So we start from the toughness and then we just gently go back to the ground. And so all this is part of the parameters, that human parameters you have to deal with, because it's just too much energy and stress. And when we removed the scaffolding, we went up there, 20 of us, 20 petals, 20 jacks we have to lower. And then, there's quite symbolic rituals in architecture that we forget, but it's quite beautiful when you think about construction as a ritual, construction as processes, not just the end product, but the means to do this, And it's quite beautiful because when we opened, they had these really, really beautiful messages of people that passed away. And it's very real. When you lose someone, you really feel it. And when you see others lose people they love, you can only relate to that, no matter where you come from, your origin, joy, pain. There's such universal languages. And it's quite touching and moving. And so Sunny, my wife and I, we decided to get married. Because it was our way to use the temple after, having a couple panic attacks, and so it was just important to remember it as a very positive thing, not just as a service or a sort of, I don't know, purely building. We have to have a meaning in life, and so yeah, it's what made it very special for us and very, very emotionally connected with, yeah, I mean, I guess important things in life. So anyways, we went back, we burnt it. I removed the slide on burning it because I feel bad about it. But we burnt it. It was a beautiful burn because everything was kind of gone. And then I thought to myself, let's go back and build something that's the opposite of Galaxia, which, Galaxia is like the temple is like here. And then we did this catharsis structure here, which was the opposite in the city versus what's, maybe we had to do this to finish the loop, but I'm kind of done with Burning Man. But at least we did something that we didn't burn, and we tried to disassemble. And it was more of a funny structure. We had Refik Anadol do projection mapping. I mean, it's just the weirdest Refik Anadol piece, but he likes it. And then we had like all kinds of performances, people getting married. We were loud. It was really wonderful. And that team effort, was really something that was very important. then I was asked to do one in Paris, which is where I'm from. I'm born in Paris, France, and it was really interesting to bring that spirit in the heart of a city that is thriving. It's still on. It's still in Paris now. I'm going next week to disassemble it. And it's actually I'm going this Friday, but tomorrow in 2 days. So we have to disassemble it and put it in Camargue in the south of France. It's going to become a bird observatory. It's just these giant wings in the movement of the Eiffel Tower and the obelisk. And it's got this central 3D printed bell, which actually will become the heart of a staircase that will then have a platform to become an observatory. It's crazy because it's, again, fully fundraised. We had to think of reuse. All of this will be dismantled, reassembled. So circularity is very hard because you have to think of the next step before you finish the first step. So you have to think of the forces of where it's going. The south of France has heavy winds. Paris doesn't. So this is engineered for heavy wind, but Paris doesn't need that. And of course, it's very tempting to just constrain it to Paris because it's cheaper. But we can't because we have to reassemble it somewhere else. So you have to fundraise even more. Anyway, so it's a nightmare, but it's a happy nightmare, as you can see. So that's kind of circularity comes with that sort of level of forward thinking in the future. That I just want to highlight that because I think it's very important. Our systems, our architecture, our systems, so they evolve in different contexts. These are 3 of those. I mean, 2, and then 1 ghosted Galaxia, let's call it like this. They're just hexagons that twist really, but they're made of timber. And then we evolved this concept several times, not just with buildings. This is a building of timber in CLT in Bucharest, in Romania. And this is in Berlin, a show that we did with Jean-Paul Gaultier, where you have these 3 of them that connect together as one system. What was interesting there is mixing the languages from Catharsis to Galaxia, and then Jean-Paul Gaultier, the fashion designer, coming and wanting it to be Jean-Paul Gaultier. And so I don't know if you know him, but he did this very sort of harsh metallic thing. And then, the language sort of clash, but it's interesting. It's this act of listening to others and trying to find a common ground in languages. And so it was a very, very nice, it's the largest stage, I think, in the world, in Berlin. And it had these 3 teams coming together, the different colors, and very symbolic and beautiful. Another kind of stage, maybe a bit different, but for the World Cup, Football World Cup, we were asked to do a shark. It's an endangered species of shark, and they wanted to do it in metal. We had 3 months. Just no way this could be done, and these towers by Foster and Partners, we just suspended a shark from Foster's tower, right? Just bonkers Qatari stuff. But basically, what we thought, okay, let's take some glasses, let's use some really cheap material because, we got to do this fast. And so we took holographic sort of glasses, HoloLens it's called. And we took rebars and then bent them. We had about, I think, 6 of these stations, 6 HoloLenses. And then we just got tons of people to just do the bending through these stations instead of using, automatic rolling bending, which can only be accessible in some factories, which we didn't have time to tender anything. We couldn't do drawings. So we just did the entire thing without drawings with the holographic glasses, mixed reality type fabrication, and bend them to the right slot. So that's David bending into the right place. And then we had another station, which was the welding station. So you just there's a second team with holographic glasses and just put it in the right spot, cable tie it, send it to the welders. And then that's it. That was the process to do it in it's pretty crazy. The team grew from 10 to 60 in less than a month. Imagine just simple things like contracts but it's that sort of versatility and resilience, that creates the impossible, and really adds the value to your business. Like I think ultimately, any entrepreneurial venture is a bit delusional at the beginning because you're being asked to do something that doesn't exist, and so of course you can't base it on what has existed already. So there's definitely a bit of madness, but anyways, on the madness level, this is FabPub. So FabPub is a side business really that started because one, I thought it's great, parametric design linked with 3D printers. It's going to completely democratize fabrication. Everyone's going to have a printer at home. That's what I thought, 13 years ago. And then I realized, of course, with the reality of printers, how hard they are. And so we created this. And then strangely enough, in the age of AI, people send us these kind of images from Midjourney, and then they're just like, can you do it? And that's what's happening really, is that with AI, people generate all these shapes and then they just don't know how to make them. And so it's perfect in a way because we're here in the heart of the city. We can train them to making, and it becomes a real, we call it FAPA for fabrication public. There's a public component to it. We're not just, we don't want to be the best fabricator out there. We just want to be a accessible fabrication place. And then as we do that, we just kind of created products, which made sense because when our printers are not used, we have the products so we can sell stuff. And of course, we create textures and, people, they like, oh, can I have that pupa light in that shape on that wall on that? So at least it also inspires, but also we can calibrate our printers to have these files. And so we, it's a mixture between fully bespoke and then partially bespoke because we don't need molds, so we can adapt the parametric model. But at the same time, like, if we let them play with the slider too much, which is tempting, parametric design is about changing parameters. But if you let your clients change your parameters, it puts the liability on them. I'll give you an example that's kind of interesting. We have a Japanese restaurant here that says, I want a stool that's, I forgot the exact centimeters, and then I said, sure, okay, let's do it. But then they started having Google complain on their Google reviews that the stools are too short and that people's back are hurting. And so people would do 1 star, the stools are not comfortable. And then they came to us and said, oh, your stools are not comfortable because they're too low. And I was like, but remember, you asked that height. And it's we don't, of course we can advise, but ultimately we give you the power through those tools. But they're not stool experts, they're not furniture experts. So there is this funny shift between empowering people, but also a liability issue, which I find very interesting that I didn't predict. Of course we fixed it. Of course we got it higher. And the power of printing is we built bases and we made it slightly higher. And so that's also the power of it, is we can fix the problem. And they didn't really blame, they paid for the extension. So in a way, it's okay. But I just want to highlight that issue because I was naive thinking, okay, parametric design, you empower everyone, they can play with sliders, but they're not experts. So they end up with a situation where they regret their own choices. So that's something to think of. So this is our silkworm. This was a tool that we developed. You have to think that G-code is very simple. It's F, feed rate, speed, X, Y, Z, the direction of where the code is going, and a vector, and then the extrusion value. It sounds simple, but then it comes with all kinds of hidden things like acceleration, deceleration. But ultimately, it's just sort of vector geometry and concatenation of text into settings, really, parametric settings from temperature to speed to. And so really, if you can sort of get into that craft, and it's a craft, then you can create speed and efficiencies and reduce the amount of material needed. And you can have precise knowledge of cost and amounts. And you can play with really interesting textures. And so this mandala, for example, happens because it's very inefficient to do a surface with printing. And so we just try to connect dots, right? And there's not that many ways to connect dots than just interconnect them. And then, and so we create these sort of patterns which emerge from just the fact that it's not very easy to do surfaces from printing. And then we created these domes and then balustrades, and that's my little Oscar testing things. And then the engineers is another thing. So liability. So let's say you're printing. So we did this with Arab, a big pavilion, once we got our robots. And then obviously you're asked for structural report, but the engineers are like, well, this is completely non-standard bespoke. So So we need to test it. So you need a testing ground for testing structural capacity, which is again completely unexpected when you start a business, you know. But anyway, so we did the test and it resisted about 500 per kilogram per meter square, which is unexpectedly strong for polylactic acid. And our goal was to create a structure that could travel. So it traveled to 5 locations: Singapore, Bucharest, Sibiu, Dubai, and now probably New York, maybe. I don't know if I should say that, but probably. And then we brought the machine with it. So we believe in local fabrication. So we put a machine in a container and made the entire system completely self-contained, from the heater, the compressor, the air conditioning, everything is integrated. So you just have to plug it. And that means that you could print on site. You know, that would be an ideal scenario, to print on site, to recycle on site, so that you minimize the amount of stuff that travels, really. We have a full recycling center here. It's a little bit funny because things have been expanding in a way that is just a little bit beyond an architectural scope. I think Sina told me to tell you about business. When you consider the full loop of what you're doing, where materials come from, where they end up, it's a very complex equation. You know, it's called a life cycle assessment. That's comparing, let's say, petroleum, plastic, ABS, PETG, and so on with PLA. And these are all the different things to consider. Land use is very bad with PLA because you use corn or sugar fields, but everything else, pretty much apart from these complex ones, are better. And so we did many projects with PLA and then got confronted on design and so on for greenwashing. And so I can't stand greenwashing. So if I'm being told that, I'm going to go deep into research. And so I went all the way to the molecular level, spoke to a chemist, spoke to a Nobel Prize winner in chemistry. And what she said, and what they said to me, all of them really, is the problem with petroleum plastic is when you look into it, it forms this hexagon structure, and that enzymes cannot eat that. Whereas when you take PLA, it's a long chain of polymer. It doesn't have a hexagon. Nature undoes and does PLA all the time. Take sauerkraut, take kimchi, take kombucha, take you name it, any fermented traditional cuisine. It forms lactic acid, kefir, and lactic acid, is then dehydrated, and the chains of polymer just gets longer, and it performs like plastic. So it's actually stronger than plastic when it's in its virgin state. It just degrades because the enzyme love it. They want to eat it. They don't have obstacle. But that's fine because you don't have these enzymes in nature all the time. And when you want to or compost this material, you need to put it in a 100% humidity, 60 degrees chamber with the right enzymes, and then they munch on it and it becomes earth. But it's not going to do it naturally. It's got a rate of degradation that's quite slow. So if you're engineering it, you engineer it for the right dimension, and then you add the year span. So you need to 5 years, 10 years, and then you add that as a thickness. So it's a really interesting thing to think with degradation in mind. We did that piece of work with Dassault Systèmes, the Katia SolidWorks guys, and looked at, well, how much, if I were to do a PLA sort of structured, and what would be the carbon input of that versus a PTS or ABS, PTG, ABS structure. And Katia had this nice add-on that measures carbon footprint as you design. And so if you build with modules, the beauty of building with modules is you can reuse them, repurpose them. Now these modules took 6 hours to print, and we thought, okay, let's think of that. 6 hours to print is a lot when you multiply that by, say, 500. Whereas here we're printing on a mold, so that's not 3D. It's like 2D, 2.5D, let's say. Print on a mold means you don't need the supports. You just, and the pattern, I keep on doing these wavy pattern, but when you think about it, a printer is on a highway. It's like a car on a highway. Like the more you turn 90 degrees, the more you decelerate. So these patterns emerge from wanting to go as fast as we can. And it, of course, it develops a sort of language of curvature, but not always. Like these are much more. This is COS, the fashion brand. They were like, we're modernists. We want straight lines. Okay, fine. But obviously, then you need to think of toolpath optimization, and these are printed flat and assembled into these sort of basketry element, and those basketry elements are assembled together into arches. This is a real modular thinking. This is exactly the size of our WASP 3MT printer, for example. So, and we know that we had access to labs that had WASP 3MT printers next to the site in Milan. So we were like, you know what, that's perfect. Let's print locally, send the files to the WASP hubs. And then everyone prints, you spread give them a bit of money each, and then we meet together and we print together. And so that was a really nice communal effort in a different way that still created something that had the elegance, of course, and the spirit of the palazzo that we're building. Hopefully we're building another structure in Milan this year, but I can't talk about it, but a similar spirit evolving. This is, so I invite you to Milan and we can meet there. Fingers crossed that will be a way to meet if you can't make it to Paris before this weekend. But this is another example of flat printing. All of these modules are actually in cathedrals. You have what's called stone tracery. It's very beautiful craft. And so we printed those and then we actually radial array it to create these clusters. And then the cluster is radially arrayed. So you array the array. And so that's really how computational design works anyways, but geometrically creates a complexity from simplicity. And it's really very powerful to link this with the aesthetics and the culture and the craft of the local church. And we printed it from PLA with wood, and we added a bit of brass to create this metallic finish so that it creates something very light. It's 4 meters long, so that's 12 feet. It's very big chandelier, but it's only 100 kilos. Sorry, I'm really bad with pounds. I don't even know how to convert kilos to pounds, but it's not much for a chandelier of that size. And think of the structure, the carpentry work, like chandelier can be very heavy. So imagine that the benefit of printing in this case is lightness. So lights are a very good place to go with printing because of that. This is printed in sand. We did this with a really nice architect called Chris Brecht in Austria. Lovely guy, similar values. And I think he was having his baby. And so he's like, I can't go to site, but can we do this together? And so we thought, okay, let's create a module and print it with local materials. So obviously, in this case, we use sand. It's in Saudi Arabia. So the sand is dried with something called I forgot the name of this resin, but it's a resin that dries this, that almost cooks the sand really, and it creates this dark finish, and then we then spread sand again on it to put it to that color. All the forces expressed, you do things with this kind of sand printing technique that's very different because doesn't matter if you have cantilevers and so on. So that was really interesting to switch. Whereas when you do FDM printing, like fusion deposition modeling, you're constrained to layers, but layers can become an aesthetic of their own, and this is coffee grinds mixed with PLA. You see these black little dots. And this is a gyroid. So gyroids are really good in all axes. It's usually used as an infill, but we just thought it was beautiful to show it as such. I used it as the balustrade of my house. That's my house, and I test things in my house all the time. So you see it here. Also the tables, the chairs. I test everything to see. If you're interested, you can go on YouTube, watch the documentary on it. We tried with my wife to just only use eco materials, and it was quite a mission. Anyway, so things are growing into larger scale stuff, and that causes all kinds of challenges. And to do this, really, the dream, that's a project we're doing in Manchester, the skin. So we have to set up fab pubs around the world to do that. So we send X amount of printers. Obviously, we need to do some kind of protective structure to create an event out of it and open it to the public. And the main thing, and maybe I'll just finish on that after 46 minutes of rambling about, the big dream that I have at least is to create these sort of temple of circularity, let's say, where you have a vertical farm that creates the PLA, let's say, or the biomaterials, and then you compound it into the materials of your choice, then you print them, and you crush them, and then you feed it back to the system, just like what we have here in London, and have places around the world that do that, and they're mobile, and we build them when we need to build a structure, and we unbuild the entire thing afterwards. in a perfect loop and circular loop and local manufacturing that will give back, the power to be creative and create things locally, whilst we can all think globally as a crew of creatives working together. So I'll just finish here. I hope you could still hear me. Yeah. And I'm more than happy to answer questions. Yeah. Yeah. I think you're probably on mute. Hello.
Hi.
Hi.
Thank you, Arthur, for sharing such an inspiring perspective on how computational design and fabrication can contribute to more sustainable and inclusive architectural practices. Your
My
work
pleasure.
reminds us that design innovation is not just about technology, but also about rethinking materials, systems, and collaboration. Um, Now, we would like to open the floor for questions. And if you would like to ask something, please feel free to raise your hand, or if you're joining us online, please unmute yourself and ask a question.
There are people online too. Yeah. Tim, Nick, Elnaz. Nice. Let me know if you have any question.
Got some shy people here.
Yay. Good job. Being the first is hard. Good.
Come on. Yeah.
Hello.
Hello.
So I guess my question is because you mentioned
Yeah.
that you are, I mean, well, looking at how your work is done, it is still
Yeah.
kind of to where you are working, but you collaborate in a team. And so it's
Mm-hmm.
really, and you mentioned starting a firm, it's entrepreneurship. So how exactly did you find yourself starting your firm to where it's like still work that you produce with other people, but it's something really that you do? Because I mean, you need like the capital and all of that. Like, how did you
Mm-hmm.
get to that point in your architecture journey?
So are you asking about how to start the firm and then keep it
Yeah.
sort of running and all the challenges that come with
Yeah,
it?
because even like the people that you found people with common values that you can
Yeah.
still work with and
Yeah.
trust to get everything
Yeah.
done. Like you end up there because I mean, obviously, nobody really starts just out of college, boom, firm. You know, you can't. There's kind of a process to get there. What did you find your process to be?
It's a good question. It's obviously hard to answer in simple terms. I think there comes a moment where you're working in an office and then you notice that there is a kind of innovation or something that's exciting about that's emerging and that's just too far remote from, let's say, the current practices, and you get an excitement about a certain way of thinking or technology, and you might suggest it to the practice you're part of. I mean, not everyone has to go through the hurdle of starting a firm, but I remember suggesting 3D printing, parametric design to my bosses, and I just didn't see that they could really understand the potential. And of
Mm.
course, I came from a very innovative school, the AA in London, and I could see the potential of natural forms and democratization of fabrication, and there were many exciting things going on, and so there comes a moment where that shift is too big, so and there wasn't necessarily places, or I would say business places. I consider going back to school, of course, but I just you remember thinking, well, if I don't do it, then what, I can just wait. But actually, at some point or another, I can probably just start it, because then I could actually design that to the full potential I can see it happening. I can see the same now, I can see AI offices being created, like the Tim Fu office. I met him. I can see a similar excitement with new technology, and maybe one wants to take it a certain way and it doesn't exist because it's going faster than we can even master it. So I think just in terms of the initial spark, it's that moment where um, you just feel like there is a potential that's there and that needs to be kind of driven in a certain way. After that, of course, no one can connect the dots in advance. So after that, you have to start. So you just like it's a decision, you know, it's a harsh decision, you know, and really ultimately it's a very lonely decision. And so you know, I talk about like pointing fingers or complaining, like you're facing the reality of market and your bank account and your friends progressing in their employment, and then you're just alone in your house. And sure, you can find business partners, but then comes the complication of aligning with your business partners. So it's a very harsh moment, which, you know, you got to keep yourself inspired. So I would read on entrepreneurship, and there's this book by, say, Richard Branson, Losing Your Virginity, and life stories that are exciting about entrepreneurship. So that's how I kept myself thinking, okay, it's fine. You know, if he's made it, we can make it. It's okay. And then you start hiring. And then so, of course, the hiring process happens when it's needed. You know, it's not something you do for the sake of doing. It's just that, you know, I was freelancing around, and then the freelancing job became a little bit too much to handle. So I would get someone, but of course, that person then comes with all kinds of delegation issues, because you lose control. Like you stop being the designer, so to speak. You're not directly on Rhino, and slowly you lose that directness that you have on your own. And in fact, it's a chance to be able to do the things yourself. And employment has that greatness that you're directly, you know, on things, depending what level you are, of course, but every level has a joy of its own. So the new joy is, of course, about looking at the meta level, whether it's the values. You talked about values, trying to define what we're about, trying to define, as you say, capital. Capital comes from the moment you need to invest in CapEx. You don't necessarily need to as an architect, because there's no machine to do architecture, and you don't really have a business model that scales. So you don't need investment. In fact, investors will be like, what's your business model? Like architecture? Well, okay, well, that's like investing in a doctor's practice. Like, why would they? They're not planning to scale. Capital comes when you scale, when they can get something out of it, of course. So we didn't need capital for the architecture firm, but I wanted to get some machines to get printing. So of course, then that's CapEx. So my first client, I talked about this business idea. Let's democratize 3D printing. But the truth is, I bought a laser cutter because I had a job that needed a laser cutter. So I just bought that. And then the printers came about, and then you know, slowly seed money, friends and family. You convince them. You send mega emails to everyone you know. People put like, you know, $1,000 here and there. The rent, I gave some shares to my landlord, and then just yeah, and then they just believe in you. But you're just alone pretending you have a business, when really you're just a person in your room trying to hide your bed from your intern, you know? And, and so you have to sort of convince yourself somehow to, I was wearing suit every day thinking that's going to be okay. But yeah, it's that for a while. And then slowly you have some breakthroughs, and those breakthroughs are really the moments that, you know, when someone gives you something more, and that's, you know, I think the breakthroughs are often moments where you take a big risk and you're like, let's just go for it. Like I could fail miserably, or I could. So I didn't show you the first part of the career, which was, you know, these shop windows and stuff like that we did, where I really took a big risk and it worked. And then boom, award, and then boom, the next one, eventually leading to the Temple of Burning Man, where then someone said, can I meet you? And then they offered to invest a couple of £1 million. So that was the moment where it was fine. Like, but it's never fine. That's the truth. It's never fine. There's no net. There's no protecting it net when you're an entrepreneur. So it's a very, very harsh path, which, you know, you can take if you have an idea that's worth it, and if that's what drives you. But do it soon. And yeah, I guess it's not for everyone, but it's obviously you can drive your destiny in that front. Yeah. Sorry, it's a long answer. I saw a couple of people disconnecting as I was answering. I hope that helped.
Yeah. Well, thank you.
Hi,
Hello.
I'm Dar. I'm also in Hyder's lab. So I have a question. You started from like, I mean, no, not started. I mean, you started from going to simulation to like full scale, huge products. And yes, so my question is that what steps did you take to go from like the design into actual product? I mean, we know from experience that there is multiple challenges, but like how what helps you to have the confidence to go full scale?
So it's a very good question. It's from design or one-off to products, which is one-off is products are you can put them out there in an e-commerce and then it's sort of repeatable and it's certified and it's almost a sort of logical step because when you're a designer you reinvent everything all the time and it's very as much as it's interesting, there is something quite passive because you have to wait for the client to come commission you. Products have the benefit that you do a body of work and then you get to improve it and then you sell it as something that's understandable yet customizable. So it's slight mutation. For me, products are like defining a DNA and changing that DNA accordingly, especially when you use digital fabrication. It's that's interesting in that sense. So I think for me, it's a natural evolution of parametric thinking. But I think your question is how it got like into larger things. By dividing the business into a clearly architectural business where we could continue innovating on architectural scale and creating a business that has its own identity, its own designers, let's just say, independent from my name, and letting it just do products and products for others and have product people and that boundary was really helpful to do that. So keeping the large scale service based experimentation and create a more product based sort of independent company, I think that was quite helpful. But it's a weird split because we have our ego as architect and then suddenly we have some place where we give away everything and then it's like where's me, where am I, and then but a little bit everywhere and you have to melt yourself and then rebuild yourself.
Yeah. Okay, thank you so much.
Thank you. Yeah, the person with a green t-shirt there at the back.
Yeah.
Hi, and thank you, Arthur, for the lecture. You started talking about, and you continued with that, with circularity and reconfiguration for the architecture. When we are thinking of circular design and reconfigurable design, one thing that is not very concrete is the site. We are kind of designing siteless. My question is how you define the connection to the context and to the site when you are starting designing something that is reconfigurable?
So excellent question, highlighting a contradiction that is inherent to circularity. Because if you're going to reconfigure, of course, it's not a site, but many sites. And so immediately comes the question of where, when, and how. The how is the size of the trucks. So the truck becomes your site. It's no longer just the place where it rests, but it's the method of transportation that becomes your constraint. So the truck driver is equally member of your design team, which is kind of a funny thing to say. So size of the truck, the climates, like the durability of your material, the connection detail that is an undoable detail and a redoable detail. I mean, shipping containers are excellent for that because they've gone through the same process. But of course, the problem is, as you say, sitelessness is a problem when it's, the international style where you lost the soul of the because everything was the same, and there was no culture integrated in the architecture. So sites can come from site specificity, technical specificity, but also come from cultural specificity. And I get one has to differentiate both. The beauty is with printing or compostability, you might have the main structure that's travelable, and then the skin could be crushed and reprinted according to local crafts and cultural artifacts. So it's not an easy answer, but say the Concordia project was sited in Paris and in Camargue, by having several uses that are phased. The main structure gave wings to the Eiffel Tower, so very site specific in Paris, but was engineered for the south of France, where it becomes a bird observatory. So we're still in that process, but it was engineered to have the platform in advance, which means like 2 uses in one, 2 sites in one. So it's it's a parallel computing of sites. But there's no easy answer to your question, because I know what you mean. Site specificity is a requirement when you're at School of Architecture, and it's the same for us. And we cannot be completely siteless. Even Burning Man is a desert, but there are conditions at Burning Man that are very site specific, both practically but also culturally, in terms of values. So there's access to the site, which needed to be considered. So yeah, it's a little bit 3-dimensional. It's not necessarily an easy one-sided answer. Sorry, it's just, yeah, don't know if that helps in any ways.
Thank you very much. It helped a lot. Yeah.
Okay.
Do we have any more questions from the chat? If not, I would like to ask one myself.
Yeah.
During your presentation, I could just see a lot of connections with my research interests, which is obviously including lattices, wood, sustainability, and even like connected in a personal level, like when you have your children working with your designs and prototypes. Like I also do the same thing with my children. So it was great to see their like. So I would like to ask something. This is something that I have issues with sometimes when I try to merge, let's say, the design, like when you try to make something safe, but at the same time, like as an architect, like I want to have something aesthetically pleasing, but also when it comes to the fabrication process of it, there might be some challenges, like in the Burning Man that you mentioned, that you had to like strap some of the joints because it was getting like too complex. Maybe it was gonna take like much time or too much money to create this joinery. How do you, like, I don't know, bring this to reality? Like, how do you come up with details? Like, what is your, like, the process that you go through to bring these complex designs to pretty much reality?
It's a great question. And it's let's say that's the strap. So, you know, when you design something in the computer or in general, right, you can't have every single answer from the start. So that's why you have different phases: concept design, technical design, and so on. But the thing is, very often you have an intent and you have structural simulation that starts from lines. We start from lines most of the time, especially with lattice work and so on. So if we were to think both detail and members and shape and site all at once, I think we'd explode like in a computer. You have to compartmentalize the thinking. But the truth is, there is so many components that will inform the decision making. In this case, we had like a 6-noded node, let's say 6-membered node, and we had 1 month to build it, and I was still fundraising, so I had skin in the game, and that was like, there's no way we could do metal work that has 6 kind of elements and in metal with bolts. The engineers want that. Of course, that's the easy solution. But the price of, I don't know, close to 400 of these nodes, the time to place them, the safety of lifting such heavy nodes, it just made no sense. And I just couldn't well, one, I didn't want to pay for it, and I just didn't know how to pay for it. So I think it helps when you're, at least entrepreneurs know that they're suffering because they see their bank account go down. So that's one of the best way to get punished by decision making. But the truth is, sure, people will make fun of me. I'm using ratchet straps, and they did. They call me the ratchet strap architect out there. Yeah, they covered my camp with straps, and just it doesn't matter. It was safe. It was cheap. We built it. Love it. Ratchet strap architect. Plus, it's interesting. It's like soft joints, like they used to do lashing before on bamboo structures, and this is rated. Ratchet straps are rated. Sure, maybe they could have been black, not pink. I don't know, huh? But yeah. Anyway, so then I go back to the Concordia we did, and we did those metal nodes, and then it's because I just had two wings, so it's easy. But still, when you do metal nodes, you have like compounding angle versus plan angles, fabrication details. So I'm so happy we went for the straps. Yeah, so I guess the decision making is growing on its own from all the constraints that are emerging, and not being fixed to predefined ideas, and not being scared of people thinking, what the hell is he doing? Using scaffolding for this and that, or like there is a dose of wildness in coming up with ideas and sticking to it and believing in it, and that structure, Concordia, some say, wait, it's not finished, or Galaxia, it's not finished, and then just embracing a little bit of imperfection, because it's what does finish even mean anyways? Like I know from Burning Man, they would use the temples before the Galaxia would be like a structure and then decorated with lots of patterns. And they were very surprised that we didn't put any skin on ours. But when you see the Eiffel Tower, for example, like, is it finished? Is it, it's not even meant to stay. It was, the Eiffel Tower is a temporary structure. It was meant to last like 3 years or something. It's the most visited structure in the world. A temporary structure that's sort of just no roof. I mean, it's quite crazy in a way to think this way. Like, we don't really know the future. Like, we could pretend, and so it's I find it interesting to sort of challenge what's temporary and permanent, and what's sort of, what our notion of architecture, or that's the invention bit, I guess.
Thank you. Is there any other questions or in the chat? Okay, then I guess once again, thank you, Arthur. We appreciate
Thank you so much.
Being able to share with us your time, work, and experience. It was great. Thank you so much.
My pleasure. Thank you so much.